wonder if it's recording. This doesn't tell me whether it's recording or not, but I will just carry on anyway, all right? Okay. All right, so this is going to be Neural Networks course, and this is the Neural Networks course by our Graduate Institute of Brain and Mind Sciences, okay? I want to distinguish first, okay, I want to distinguish this from maybe, because of the way the world works now, this is to be distinguished from similar AI or neural networks courses or computational courses that might be conducted in computer science or engineering or electrical engineering, okay? This is going to be different from them, very different, okay? Very quickly, very different. Maybe we have some common fundamentals or basic stuff, but our goals and our kind of conceptualization is going to be quite different, okay? So it's unique in that perspective. Key difference is that in engineering or computer science, it's very much applied in the sense that neural networks is what all these AI, large language models, you guys have heard of ChatGPT, all this kind of thing. They are all neural network models, okay? But in the engineering and computer science fields, they are concerned with how do I get this neural network to solve certain problems? Can I make it do better? Can I tweak it? And then how do I scale it up? How do I integrate it? So they're concerned about the engineering side of things. How do you use it? How do you apply it? And as far as they're concerned, it doesn't matter what the neural network, how it so-called works. Not how it works is not the end goal. The end goal is, does it work well? Okay? But if to the extent that knowing how it works helps them to make it work well, then of course the comp science and the engineering fields, they will be interested in that. But that is never the end goal, so to speak, or at least, I mean, in general. I don't want to put words in people's mouths, but some specific courses might be interested in theoretical stuff, but as a field, the field is more interested in the application as the end goal, okay? Here, our end goal is to understand how it works. Whether it works well or not, or whether we can apply it or not, like some kind of reverse, it's not so important, okay? I mean, it would be cool if it does, right? Because if it works and it works well, it itself is a signal that maybe we understand things quite well, okay? But that is not an end goal. Our end goal is to make sure that how we understand how it works, and if our understanding accurate or not, and how do we validate that, okay? So right from the start, I want to distinguish the difference between our course here and these other courses, okay? Because in the past, maybe some people come in and they expect like, oh yeah, I'm going to deal with ChatGPT and all those kinds of stuff. Sorry, we actually don't use ChatGPT at all. In fact, we are not going to care anything about how all these commercial applications you guys are very familiar with, so to speak. We don't really touch on those. And even after you complete this course, you still probably can't really understand ChatGPT or LLMs, so to speak. I mean, we will introduce some of that, we'll make some connections, okay? But the fundamental approach of this course is really to build your own neural network model from scratch. So we won't use all those like TensorFlow, Google has the neural network thing, or if some of you have dealt with some Python thing like Torch, all these are neural network packages that these companies, they use to make LLMs, ChatGPT, all this, okay? But we are not going to use that. We're just going to use simple mathematics to build our own neural network model, okay? So from the perspective of goals, all right, and what the world commonly understands neural network models to be, or they call it AI, all right? And in terms of the tools that are being used, this class is really quite different from all of that, okay? Any questions about what I just said? At any time, if you want me to clarify, or if you don't understand, if you need it in Chinese, or if you want more details, yeah, just raise your hands. As I said, this class is meant to be small. so that we can really focus on everyone who's here, and that you can feel free to engage in a very kind of comfortable way. All right? Okay, so that being said, that is the overall arching framework that I need to clarify first. And then now, this is the first lecture. Today it's going to be relatively light, all right? But, and then next week is right? So it's a break. And then we will really start in the third week, okay? So we have about 2 weeks, and I'll show you later, for you to kind of ramp up a little bit on the reading and the background. And then in the third week, we will really kick things off. But today, I just want to make I'll settle some of the administrative stuff, and then give a brief intro about something a bit more conceptual, but light. And so we'll probably not take up too much time. And I do apologize that I had to start late today because I was supposed to do some errands in the morning, but I ended up not having to do it, so I just came, and then never mind, we just relaxed for a while, and then we started at 10. Okay, so let's go into the admin part. The first thing is, for those of you who are registered, obviously you can access this NTU Cool webpage and you can see things already. Those of you who were not registered before, then you need to, this is actually open. So if you go to that web page URL, you should be able to see everything as well. But the key thing is you would not get the automated notification and the linkages. So for some of you already told me, and what I did is, because we are waiting for the formal registration on 3rd of March, 3月3号才有那个学校的消息. So for that, until then, what I can do is I can add you as auditing, okay? So maybe you can I'll set you up as auditing, so that I can kind of use this to broadcast messages, or you can also access the content more directly, okay? Until 3rd of March, hopefully, if you make the applications, then you will be able to be a formal student, all right? So in terms of registration, any issues about that? No? No questions? All good? All right. Okay, then this course will be at 9, we will start at 9:10 every week, okay? It's just today that's a bit special. If there are, obviously if there are any last minute changes, I will announce, and hopefully you guys check your email regularly, so keep that in mind. And one thing about this physical classroom is that, just to introduce to you guys, some of you may not have used Future Classroom before. Future Classroom, this is a Future Classroom. What it means is that there are more TV screens and electrical outlets. So it's a future about it, okay? Excuse me. So, and they also set up like a very convenient video recording. I hope it works. I'm recording this session now. Your faces are not recorded, only the backs of your head might be seen. So no need to worry about your identity, all right? We keep that. Only my identity is seen. And I hope it works. Okay, we'll see. I will only know after the class. But I won't be recording every session. Only sessions where, well, I guess quite a few, where I'm talking about more conceptual stuff. We do want to record that as much as possible, so you guys can revise or review after class if needed. Hopefully you don't need to. Hopefully the things we talk about are just things that you can just absorb, and you don't have to really work so hard apart from the readings. Okay, so back to this. So in terms of this course, this classroom, the reason why we want to use this classroom is because this, as I said, is going to be more of an interactive lab thing. There's going to be quite a bit of coding, okay? So you guys should all have your own laptops, and your own laptops should have, and we'll talk more about the software needed, should have the systems and the applications you need installed. I can't spend time to worry about your software environment and things like that, okay? But the good news is, as long as you have a Google account, you should be able to run most of the, if not all of the neural networks, all right? So I don't expect much of software requirements to be an issue, but you will need your laptops in every class, and also therefore you will need electrical sockets. So this This room has, every table has power outlets, okay? And a good Wi-Fi system, and we'll come to that in a bit. And plus, if you want to collaborate with each other, these screens can all be kind of like, you know, independent so that you can share your work with others in the screens as well. And they are all touch screens, they are the same, you know, setup and all that. So this kind of multimedia setup is ideal for what we do because we are doing things that are very much about visualization and collaboration and coding, you know, and require computer work, all right? And also, these tables are all, you can feel free to move them and you don't have to sit so like, you know, so neatly all the time, okay? You can treat it as your own desk and you can move it however you want. I don't care. Actually, a little bit of mess makes people feel good, all right? More relaxed. If everything is so organized and all that, people feel very uptight, and we don't want that to be a limiting factor here, okay? All right, so that's for this room. Another thing about the room is, as I said, there's pretty good Wi-Fi here. If you are using NTU PEEP, that's not good Wi-Fi here. Apparently the signal, although you can see it, but apparently the communication for NTU, the main Wi-Fi, or NTU PEEP, okay, is not so good. So the recommendation is that if you go to your Wi-Fi, you should be able to see Future Classroom EduRoam. There should be a SSID there, okay, that's Future Classroom EduRoam. But it is an EduRoam account, it's an EduRoam kind of setup. So if you have EduRoam for NTU set up before, then you can just enter your EduRoam password. That's not the same as your regular NTU password, okay? It's a separate thing. If you have not, then go here to the register link. And this is the Jizhong Computer Center's account. And this is the same place where you set up your email and your Google, NTU Google account if you guys, and VPN, all right? So for example, if I log in, you'll see that there's these services, okay, VPN, email, and the EduRoam. So go ahead and set up your EduRoam account, and then I believe it won't be instantaneous. It might take 15 minutes to half an hour to a day. I'm not sure, okay? But you should do it today so that the next time you come in, you will have access to the Future Classroom Wi-Fi, the EduRoam Wi-Fi, okay? And so this is highly encouraged. Any questions about that? It's pretty important. All good? Okay. All right, so that's by way of the course registration, the classroom setup, the weekly things. Any questions about all of those administrative, logistical stuff? Okay, if not, then I'll go into the course details. Let's talk about the objectives, okay? So as I said, this course is distinguished from, let's say, an engineering or computer science course because we are not interested in making apps or programs to solve problems, so to speak, like ChatGPT or LLMs. We are instead fundamentally interested in knowing how the principles, okay, and of how neural networks work. All right? And the key reason for this is, I assume you guys know, we are in the Graduate Institute of Brain and Mind Sciences, okay? The brain is effectively the brain is a neural network. In fact, the notion of a neural network comes from the brain, all right? So you have to recognize that although these ChatGPT or LLMs, AI models, kind of like are in engineering or computer science, actually neural networks, or the idea of it, started from neuroscience, okay? It's called a neural network, okay? Its reason is because some scientists long time ago, some biologists rather, okay, long time ago, took a microscope, saw that this brain that seems to be important for our behavior, and they saw that, hey, what is the brain made of? And they saw these neural cells, call it neurons, right? And that these neurons are connected to each other, and somehow in that we get all these complex behaviors, okay? And that idea was then taken by computer science people or engineers or mathematicians and all that. And really, back when it started, people didn't really distinguish between, are you a neuroscientist, are you a mathematician, are you a physicist or what. It's like, as long as you're a scientist, it's kind of like you need to know all these things, all right? And I believe that's a healthy thing. I believe even now we should be doing that. You shouldn't say like, oh, I'm a psychologist, or I'm a biologist, or I'm a physical therapist, right? And then I only know my field. No, you can't afford to do that really. You really need to be multidisciplinary now. That really is the stage. And so, because actually that's how those scientists were, okay? And so when we bring that to this class, we should always remember that yes, there are these large LLM models and all that out there, but the core of it comes from this notion that they are driven by neural networks. These AIs are instantiated by neural networks. So it's very important to understand what is a neural network, how does it work, why does the way it works give rise to AI or give rise to behavior, okay, that the way we see it, all right? And we will go into a bit more detail later on about this. The first objective is after this course, hopefully all of you will have some idea about how neural networks work. You probably already have some initial idea because nowadays the resources are available all over YouTube, right? And all these online tutorials. But hopefully after this course, you will have it even more solidified and more concrete, okay? Because you will actually make your own neural network, okay? And I believe, I'm a very staunch believer that the best way to learn is to do it, to make it. If you can make it, it means you know it. If you know it, but you think you know it, but you can't make it, you don't really know it, okay? But if you make it, you can only make it well if you know it, right? So if you have made it, you can be a bit more confident that you probably know something more than if you didn't make it, okay? So we will be making some simple neural network models. We won't be making ChatGPT, LLM, I emphasize again, but we will be making, I would say, 3 fundamental kinds of neural networks that in the way they operate, you will see actually that the way they operate are very base principles that you might catch in these now very complex models. As complex as they are, we are still just running these 3 basic principles, okay? You'll see that. Well, hopefully you'll see that. And then not only will we make the neural network model, after we make the neural network model, we have to ask, well, how do we know whether it works or not, right? So we also have to learn what are some approaches or frameworks we use to, we say, evaluate the neural network model. So it's not enough to say, oh, I can code and then oh, it looks like there are some neural networks doing some computation. But we need to have some organized principle to evaluate these neural network models. So this course will also teach you how to do that. And by evaluating, really what we mean is we run simulations, okay? We formulate some ideas and then we set up our simulation and then we see if the results kind of match what we expect, all right? Okay, so those are the key objectives. And you can read all this one on your own, but these are the kind of we will make these 3 basic models. The first one, the basic perceptron, is more like an introduction, okay? So you will need to know that, of course, but we will, after that, very quickly focus on these 3 different networks. We call the Hopfield network, it's an attractor network, and we'll kind of define that when we get to that. And then we will have the error backpropagation network, okay? And then we will have self-organization using unsupervised learning. All these jargon, all these terms, we will talk more about that later. But very briefly, I would like to introduce you. So Hopfield should be known to all of you because the guy won the Nobel Prize, right, for physics. Even though they are not physicists, they are computational people, right? But they won the physics Nobel Prize. He shared the Nobel Prize. John Hopfield shared the Nobel Prize with the other guy. What's his name? I'm blocking on the name now. But he's the guy who did the other guy who did, who won the Nobel Prize was doing this error backpropagation part, okay? So Hinton, yes, Geoffrey Hinton, okay? The other guy who won the Nobel Prize, okay? And these two, you will be reading their papers, Nobel Prize winners. You will read Hopfield 1982, okay? That's his Nobel Prize paper, okay? So then you guys know what it takes to be a Nobel Prize person, okay? And also, Hinton didn't, it's not like any specific, I guess there was that paper he did, but what we will read is kind of like his collaboration or his colleagues, not necessarily his own paper, but they were talking about how to use error signals to train neural networks, okay? And that is actually all of what these LLMs are doing, all these neural AIs are doing, okay? So we will be using those very powerful principles as well. And then last, von der Marsberg, not as famous, but I would say he started this, or kind of tried one of the earliest attempt, okay? You can see in 1973, one of the earliest attempt to try to use a neural network to kind of model how our brain is organized, okay? So that's what about self-organization, all right? So this is also critical because you see, like, apart from having the ability to learn, in learning, these neural networks sort of kind of have some emergent organization that we didn't teach them to be organized this way. We were teaching them something else, but then they emerged to have this kind of ability. Sort of like how LLMs, when you just feed it large data and then it emerged some kind of higher level behavior. How did this organization occur? So these are the three main, I would say, fundamental strategies or algorithms. We will cover them a lot in the class. All right, so I emphasized this already, okay? And prerequisites, we don't have to talk so much about it, but essentially, as I said, you're gonna need your coding computer, all right? And please, know that I can't be spending so much time to do the technical stuff. So you will have to try to struggle through the technical stuff mostly by yourself. In other words, you have to be able to work and solve problems independently as much as you can, all right? I mean, of course, I'm open, you can email me, but try to work independently as much as you can, all right? Okay, what are the coding environments we will use? As I said, we will use Jupyter Lab or Python or Google Colab, okay, which is a Jupyter notebook, okay? So, and I will be doing demos in class using Colab as well. So as long as you have a Google account, you can use Colab, and you should be able to run this. But if you want to, I do not restrict it. If you want, some people are already deep in coding and they don't like the Colab, they already have their computer set up. Feel free to use whatever computer environment you want. You can even use MATLAB, you can use R, you can use native Python. You don't need the notebook environment, that's fine. But I'm just going to use the Google Colab because it's just an easier graphical interface and easy for teaching, right? But if I were doing hard coding and like upscale stuff, I won't waste time with Colab. I'll just go directly in Python, for example, okay? So these are the possible but not restricted environments to use, but not restricted to these, okay? So just to let you know, you should set up your computer so that you can be familiar with this. That being said, if you have no coding background, okay, this is a good time these couple of weeks also to go, because now I've introduced to you these are the environments we will use. Pick one of them. I suggest you use Jupyter Lab, okay, and go Google it, go see some YouTube clips to learn how to basically code using Python or Jupyter Lab interface, what it's all about, okay? There are many, many resources out there. I think you just Google, how do I use Jupyter Lab or Google Colab? There should be someone who already has recorded a video to show you. Okay, so this is a good time to go and brush that up, if you haven't already, okay? Okay, and then, excuse me, grading. In this course, we will have grading in two kinds of formats. One would be the homework tutorial exercises, and those I will count as complete or incomplete, meaning that if you did it, whether it's right or wrong, or how, whether you'll get the point, okay? But do something, right? Don't hand up a blank submission. As long as you do some work and you struggle through it, and you hand something up, you submit something, you will get it complete, okay? And that will occupy, let me check below. Oh, I didn't write it down. I think it's in the syllabus. I'll update it later, but I must have put it there somewhere. Oh, I didn't put it there. I didn't update it. I'll update it. That should occupy kind of like, I would say 10 to 20%. Where was I? Yeah. I would say 10 to 20% of it. Let me update this, okay? But it will be like, not less than half of the course, okay? But it will be substantial also. So if you submit quite everything, then it will really make a difference, okay? Then the meat of the assignments will be the 3 assignments, which are the 3 neural networks I talked about, the Hopfield, the backprop, and the self-organization, okay? And don't worry, these assignments, there will be guidance to guide you on how to do these assignments, to make these networks, and to run the simulations on these networks, okay? And then you kind of like, as you work through it, you submit your code and you take snapshots of the outputs or things like that, and then you piece it together into a report, okay? And then you submit that assignment, and you will get those points. And so each of them will occupy the remaining percentage equally, okay, of the grades. All right. So any questions about the grading and just now all the coding and all that? All okay? Are people worried? Does this sound like too much? Let me give some assurance here, sort of in the rubric that I will use, okay? First of all, I'm not here to care about your grades, okay? I really don't care about the grade. To me, the grades is just kind of like feedback, that's all, okay? About how much you participate, how much you engage, all right? This course is not about filtering like because there are some gradings or exams where they need to say who is the top or who is the last so that we can have some sort of filter, right? Because we have limited resources, we compete. So not everybody can get the money. Only the first person can get the money, something like that. Those kinds of exams are not this one. This one is about like feedback to you about, hey, you didn't seem to be engaging, all right? Or you engaged, and so I have no issues with you in terms of the engagement in this course, all right? That you have learned the material, okay? So this is different. This is not about filtering. This is about acknowledging, giving you feedback for your performance. So on that note, for the assignments, you will try and you struggle, and if the way you do the programming of your own neural network model is successful and you've applied it, then of course you must have learned it. As I said, if you make the model and it works, then you must have understood something, okay? So then that's good. But if your model is not so successful, that's not a breaker. If your model doesn't work, you can reflect, why didn't it work? Where did you get stuck in your understanding or in the coding? Is it the understanding, or is it a coding, or is it something else? So part of the problem solving iteration, right? It's not like you must make it work, or that if it doesn't work, then that's the end. But actually, if it doesn't work, why doesn't it work? And maybe within this 12, 16 weeks, of course, you can't solve it yet, but maybe after you will. But let this be a beginning. Like, you've started this task, so even if it doesn't work during this course, log like why didn't it work, and where, how are some possible steps I could try next to get it to work. and then it's a learning process. Even after the end of the 16-week, you have this document, you know, in your own time, you can go back and struggle with it some more, and maybe sometime in your life, you get it to work, and at that moment you feel like you understand something. So this course, I never take the perspective that within 16 weeks you get everything, right? It always everyone has a different kind of learning path. So this is a learning part of the process of you learning these neural networks. So model success is a subjective thing, okay? If it's successful, it works and all that, of course. If it doesn't work, well, what I want to see is like your thought process about why troubleshooting and a plan for getting it to work in the future, okay? And that is where this comprehensiveness and strategicness of your model evaluation comes in. You can see that, right? Like if you tried this and it didn't work, if you tried this and it didn't work, and it makes sense and all that, then there should be a path that's clear that, yeah, you're on the path of getting it to work eventually, okay? So by that token, you know, it's a very, again, relaxed kind of assignment requirement. It's not really hard that like it must work and then that's it. Okay, that's very stressful. No, this one is about like growing together, growing your knowledge together, okay? And that being said, homeworks are bonus credit. So if you submit everything and I have this flexibility where I can give you, like, you can get more than 100 points, all right? So that, you know, even if your kind of like the assignments are not so good, like, or you feel like, I can't really do a lot, if you do your homeworks and all that, I'm fine with adding that as additional credit, okay? So that you'll still get a good score for the class, so to speak, okay? So in other words, the rubric I'm using is very flexible. I'm not here out to kind of make things difficult. So if you feel stressed or anything, don't feel stressed. I hope you enjoy learning. For me personally, this is one of the more fun classes that I teach because I enjoy learning about neural networks because that's really my core interest in my research anyway, right? I want to know why these things are wired together, and then, hey, we can get human consciousness or, you know, complex behavior. I mean, that's mysterious, okay? We still don't know that yet. Or as powerful as all these AI models are, we still don't really understand how it works, okay? Not the same way as we understand how many physical or even chemical things or even biological things work. We know very well how the heart works, you know, how our digestive systems work. We don't know how the brain works, sadly, the most important thing. Okay, any questions about that? No? All right, then just overview of the schedule, and then we'll take a break, and then I'll continue with today's kind of like intro, very, very brief intro, okay? So the schedule is going to be like today is going to be the introduction of the logistic admin stuff, and then later on I'll talk about the general motivation, okay? And a bit more of a conceptual introduction. Then next week we will have a break because of Memorial Day, but because of that, please do see if you can take time to start reading these two readings. Jordan is about linear algebra, okay, which is going to be about matrix, vectors, and how to manipulate them. Can I check how many of you are from well, should be right. 都高中都有做 matrix, right? Everyone should be confident with matrix. Who is not feels like they are like very scared of matrices? Like, oh, 这是什么来的? Yeah. Okay. Don't be, okay? But if you are not so confident, if you haven't touched mathematics for like years, okay? The Jordan reading is meant to kind of warm you up again to understand what vectors are, what matrices are, how to use them, okay? So that will be a good time to brush it up. If you're already confident, then don't waste your time, all right? Be confident and then you're fine, you can skip it. But if you're not, then this is a good resource to kind of brush up on your linear algebra. Matrix operation and all that are basically linear algebra. That being said, do not limit, if you need to, don't limit yourself to the Jordan 1986 paper. I'm sure there are, again, better YouTube clips that are more efficient. People have spent a lot of time to make tutorials, videos that, like, if you watch it, you understand it better than spending hours reading Jordan paper. I'm just putting it there because it is a go-to base thing, but if you have better resources online, feel free to use them, okay? But this one, Agarwal 2018, Chapter 1, I think it's a good reading that you should spend time reading, and that will be a primary kind of focus fundamental in this course as well. Because I think Agarwal kind of writes a lot of the concepts, the mathematical, the theoretical, and the computational implication. I think he outlines it very well in the first chapter at least, okay? So that I think actually once you read the first chapter, you kind of get the whole, what a neural network is, at least at the fundamental level. You haven't yet applied it, but I think the principles are there already, okay? So hopefully you can spend that week, these 2 weeks, brushing this up. And as I said, if you're already pretty confident, then go brush up on the coding. All right, and then when we come back, I will go through the linear algebra again just to make sure everyone is okay. But if everyone's pretty confident, actually I can just jump straight to the, push the course earlier on. That's fine with me. We keep things flexible. But I'm putting this in this order because it is necessary. It is necessary for you to first be confident about, especially about matrix operations, because in coding, that's what you're going to be working with. You are going to code matrices, and you are going to operate on the matrices, and that is the neural network, all right? As complicated as a LLM is, or ChatGPT is, what it is a very, very complex matrix. It's a tensor, okay? Which matrix of matrices, if you want to put it that way, okay? So that's going to be the first formal lecture. And then after that, we will talk about perceptrons. We might talk about perceptrons earlier on, but that will be the next topic. And perceptrons are the most fundamental of neural networks, okay? And we will have, so that will be covered, covering Agarwal Chapter 1. And there will be, those are the homework assignments 1, 2, and I think that's it, right? 3? Yeah, I think those are the 2. And then there will be a Colab notebook simulation. I will demo to you. And then after that, we will talk about attractor or hot field networks for about 3 weeks. Again, if you can go faster, we'll go faster. If we require more time, I can pull it, extend it, okay? And the way I will do it is, when we come to that kind of network, I will talk about, first I will spend the first week talking about the principles and covering the implications, okay? And in sort of like basically going through the paper, okay? And then after that, I will demo how that's implemented in code. So the first week is theoretical, not necessarily any coding, okay? But then the week after, then we'll be translating it to code. And then the third week will be like, okay, so how do we evaluate the code? Okay? Again, these do not necessarily mean that we will do things neatly like 1 week at a time. We might squash it or might extend it, okay? Yeah, in between there will be 那个清明节, right? So then we'll have a break there too. And then there will be an assignment 1 that I put there on the 11th of April. But let me first highlight though, and I have this, I do need to mention, these homeworks and these assignments were like, I carried them over from when I learned neural networks back in my PhD, okay? But I'm feeling that nowadays, the questions, I do need to update it a little bit. So you can go and take a look at it now, but don't go and do it now, okay? I might go and change the format of some of the questions in the assignments and the homework a little bit more. I don't think too much. The spirit will still be the same. The point is to help you to make an autoencoder or hot field network, okay? But the way I approach it might be a bit different. But I put it up there anyway so you can take a look, and then in terms of handing in the assignment, once I release it, usually I'll give students about 2 weeks to submit it, okay? But since you know that there's going to be a assignment, you can start looking at the assignment even when we are talking about the attractor network at the first week, okay? You have that open flexibility. Then after that, we will talk about backprop. Same thing, I will talk about principles first, then I will do the translation into coding, and then evaluation, all right? And then finally, same thing, I will talk about the unsupervised learning or the self-organization, principles, translation to code, and code evaluation, all right? And then the last few weeks are kind of like buffer weeks, which if we have time, we will fill it up with some, I will discuss slightly implications for other kinds of neural networks that I didn't touch on, or rather different kinds of architecture based on the same principles, okay? For example, recurrent neural networks or RNNs, or convolutional networks or CNNs, okay? And then how that fits into things like deep neural networks, and how that fits into things like LLMs and ChatGPT, which we all hear about nowadays. And then finally, if there's time also, we'll talk about some general problems in terms of how that neural networks face that they are still an ongoing concern, okay? If there's no time, we will skip this. If there's time, we will talk about it, all right? It depends on how the course goes over the weeks. Okay, so that's the schedule, and those are the readings. Any questions? So the key readings will be these, okay? Agarwal is the most important one. This one, number 2, okay? And then for each of the neural networks that we will be making, they each have a paper or a chapter, okay? Excuse me. So, any questions? This is the course admin before we take a break, and then we'll come back and talk about the biological concepts. Any administrative things? 有没有吗？没有，都 OK。好，有没有人害怕或紧张？有啊。It's take it okay. When you are doing something and you feel nervous or anxious, whether you're not sure whether you will be good or not, or how it will turn out, you are uncertain about how you will perform at the end. Don't think about that. Think about that you are going to learn something interesting, and it's supposed to be fun. And so that even if you make a mistake, think of it like you're just playing, okay? When you are playing, it's okay to make mistakes. It's okay to fall down. It's okay to, let's say you are playing a soccer game. It's okay to kick it and then the ball goes out and then you miss the point, right? It feels bad, but it's okay, right? It's a game. So think of it as a game, as learning how to play. Let's say you're making Lego. It's okay to put a wrong piece. Let's just take it out and put another piece, or and you don't know what you're gonna make, but as you make it, it takes its shape. So think of this course as like that. Okay? All right? And it will be okay. All right? Don't worry about it so much. Okay? That's the way I look at it anyway. Like these neural networks, I have been struggling with it since I learned about it in graduate. I'm still struggling with it because I'm still constantly learning that, hey, wow, they have many different ways. It's not just my initial understanding. There's still many amazing things that I'm seeing, like, hey, wait, it's also doing this, it's also doing that, that kind of stuff. Or I can do this thing in a better way and all that, all right? Because when I started doing this, we didn't have Google Colab, we didn't have Python or Jupyter Notebook. What we had was stupid MATLAB kind of thing, and then it's like R is free MATLAB. Wow, okay, so I download R, and then I do everything in R, and then it's like very slow, and I use a very old computer, and it was fun. And then now we have amazing, cool tools that do, and then because of that, you can do things much more efficiently, and because of that, you can gain deeper insight as well. So it's always a learning process. I'm still learning about it. So take this as your initiation into this thing. And also, I would say that learning about neural networks this way informs your own research about the brain or neuroscience related stuff in other ways. Because the brain is a neural network, if you understand that, hey, the brain cannot possibly, because I programmed the neural network this way and it didn't work, so it can't be that the brain does that either, right? Or similarly, I think the brain is like this, I put it in there, and then this doesn't do that, so this must be wrong, right? Or how I understand the brain to work must be wrong, right? So there's that very, very important element. Plus, you realize, if you work with this long enough, this is not just about the brain. A neural network is a node connecting to other nodes, okay? Pretty much everything in our existence is about a node connecting to other nodes. It's essentially a graph, a computational graph. So, like Taipei Jieyun is a network. The world's airline system is a network. Road system is a network. Your social circle, your friends are networks. Concepts and memories are networks in an abstract sense, not just that they are in our brains, but in a sense of how those information is organized is a network, okay? So by implication, anything that the neural network you learn here does can be applied to any domain, not just the brain, okay? It's just that the brain has its own constraints, biological constraints, metabolic constraints, right? And time, it only grows at a certain rate, which is due to metabolism as well. But as opposed to that, social networks are different. They don't have the same kind of constraint, but it's still a network, okay? So there is very fundamental implication. If you learn this right, it will inform you in layers and layers and layers of other domains as well, because it's so fundamental, okay? All right, so if there are no further questions about this part, the admin part, let's take a 10-minute break. After 10 minutes, let's say about 11 o'clock, yep, we'll come back and then I'll talk about just some brief overview of some conceptualizations and the academic approach that we will take, okay? All right, so let's take a break and we'll come back in 10 minutes.